All right, so we're going to graph each of the piecewise functions and state whether they are continuous or discontinuous. And if there is a discontinuity, you state where. All that means is discontinuous at x equals whatever. So like on the flip book, it was like discontinuous at x equals 3. You know, like that's all that means. I also want us to practice evaluating these. So like, let me give you a few values to evaluate for this first one. So like, say I asked you to do f of 0. Oh, whoops, I'm sorry. Well, I can see it. Sorry. Yell at me. It's okay. There we go. Yeah, I know, right? I'm so sorry. All right, so if I asked you to do f of 0, all you have to do is decide whether you're going to plug 0 into the first piece of the function or the second piece of the function. That's it. So where does 0 live? Is 0 smaller than 1 or bigger than 1? Smaller. So you're going to plug 0 into this piece. That's it. You're just making a decision which piece it goes into. If you made a flip book out of this one, your cut would happen at 1. That's where the domain is getting cut. So if you plug 0 into this first piece, 2 to the 0 power is 1 minus 4 is -3. So that's how you evaluate. All you do is pick which piece you're going to plug into. Now, say I asked you to plug in 1. Now, that's where the cut happens, so that's a little trickier, but is it going to be the first piece or the second piece? Why the second? It's where the equal to, that's where 1 lives. Now, if you plug 1 in there, there's nowhere to plug in 1. You're just going to get 3. It's a constant function. And so say I asked you to plug in 5. 5 is bigger than 1. Last time I checked, you would plug 5 in here, but there's nowhere to plug it in. Again, it's constant. You would just get 3. So again, all you're doing is choosing which piece of the function to plug into. All right, so there's a couple ways you can graph these. You can ignore where the cut happens and just graph the entire graph and then erase the part you don't want. Some people like that. Or you can kind of, well, this is what I prefer to do, is plug in where the break happens and then only plot points to either side of that. That's usually what I do. Now this one's what type of function? Let me throw that question at you. We were exponential. We're going to give it a name, exponential, and it moved down 4. So I'm going to go down 4 and dot that in. But I kind of only need it on this side. Because again, if this was like a flip book, our cut would happen at 1. So we're only going to graph this graph up until 1. So then what I would do is I would plug in 1 and some numbers smaller than 1. Hey, but Ms. Cole, you can't plug in 1 to that because there's not an equal to. You can plug in 1. You will just put what kind of a circle? Open circle. So you can plug in 1. You're just going to put an open circle. So let's plug in 1. This is how I do it. I just always start where that break's going to happen and plug in points on either side. So if you plug in 1, 2 to the 1 is 2, minus 4 would be -2. So you get 1 -2, but just put it as an open circle. And I talked you through that verbally, but if you wanted to make an XY table, you could always do that. Now you're going to want to plug in some numbers smaller than 1, like 0. We already plugged in 0. When we plugged in 0, we got -3. And that's actually good enough. It's going to just follow along the asymptote like that. It would be a swoop. It's just we only got part of the graph. What you're doing is like amputating the graph. Does that make sense? Like you're just cutting off that part of it. It's piecewise, so you only have a piece of it. And then we're going to graph just the constant function 3. That would just be a horizontal line at 3, but you only want it from 1 onwards. Again, 1 on the x-axis is where our cut would be happening. And what kind of circle are you going to put at the start of it? Fill in, it'll be a closed circle. So we want a horizontal line at 3, but we only want it from 1 onwards. So it ends up looking kind of like a clock hand. And that's it. And then we're going to state continuous or discontinuous. So what do you think? Yeah, and we can abbreviate that. Discontinuous at x equals. So we're just going to try that a few more times, right? For number 2, the cut would happen at 3. If you were making like a flip book out of this one, that cut's going to happen at 3. So what I would do is here, let's try and evaluate some numbers here. Let's say we're going to evaluate 3. Which piece does 3 get plugged into, the first or the second? First, good, because that's where 3 lives. That's where the equal to is. If you plug in 3 there, 3 squared 9, 8 minus 9 would be -1. Let's say I asked you to plug in 7. Which piece would 7 get plugged into? Yeah, because 7's bigger than 3. So if you plug in 7 there, 7 minus 4 gives you 3. And then let's just try one more. Let's try 2. Which piece is 2 going to get plugged into? First one. Okay, I think we've got the hang of that. I won't make you do anymore. But if you plug in 2 to the first piece, 2 squared is 4. 8 minus 4 is 4. Because if I ask you evaluating questions, they're that easy. That's all you have to do. All right, so doing the first piece of this, if we plug in 3, we just did that, you would get -1. It's going to be a closed circle at 3, -1. Because there's the equal to there. So if you plug in 3, you get -1, closed circle. And then you want to plot numbers smaller than 3. And what shape should this be? This 8 minus x squared, what should that look like? It's a parabola with what done to it? 2 somethings. There's 2 things that have been done to it. What's been done to it? If I write it this way, will it help you? Good, reflect x-axis and up 8. Just, it was backwards, so I confused you guys. So you can actually go up 8 and put a point, and then it should be upside down. So that's like where the center is going to be, and it's going to do something like this. Let's get a few more points though. We already plugged in 2. When we plugged in 2, we got 4. And you can get the symmetric point on the other side. And actually, we already have 3 -1, so you can put that symmetric point as well. I think that's enough. That's enough points. We have 5 points on there. That's pretty good. You just want to plot points until you have enough. But notice, this side has an arrow. It goes on forever. That side stops. That's where the cut happened. 3 is where we cut it off. That's like where it got amputated. So when we plugged in 2, we got 4. And because it's a parabola, I just did the symmetric one. But you can always make an XY table and keep plugging in numbers. I kind of just was like, oh, it's going to be symmetric. So I put the point on the other side. But just remember to stop it there. All right, and then this one, you can plug in 3. That's the common mistake is people are like, well, you can't plug in 3. You can plug in 3. You're just going to put an open circle. So if you plug in 3 to that, what are you going to get? -1. So 3 -1 would be right here. I can't put an open circle on top of a closed circle. What happens is that they just link together. All right, so that's going to be there. And then let's plug in some other numbers. Like let's plug in 4. If you plug in 4, what are you going to get? Yeah, so 4, 0. And then actually you can just use the slope. The slope is 1. You can go up 1 over 1. I think that looks cool. Looks like a ball bouncing or something. I don't know. That's what it looks like in my brain. All right, so continuous or discontinuous? Continuous. Because the 2 pieces met up. All right, for this one, this is a cube root. It moved left 5 and down 1. So I would do that first to kind of find the center. We went left 5, down 1. So that's where the center is. And our cut is going to happen at 3. So that's all the way over here. So actually, let's go ahead and plug in 3. We can plug in 3. It'll just be an open circle. If you plug in 3, all right, ready? 3 plus 5, 8. Cube root of 8, 2 minus 1, 1. So you get 3, 1, but it's an open circle. And then let's see, I want like at least one more point here. It's gonna wiggle like on its side like this, but let's get like one more point. Let's plug in, what would this be, -4. Let's do -4. -4 plus 5 would be 1. Cube root of 1 is 1, and then 1 minus 1 0. So you get negative 4, 0. And actually, you're going to get that symmetric point here. It's going to be a wiggle. And again, you only get the arrow on the one side. 3 is where the cut happens. And then this is always nice when you see constant like that. That's just going to be a horizontal line. You're just going to have a horizontal line at 4, except you're only going to draw it from 3 onwards. And you're going to put a closed circle. And it looks like a clock. So it's a flat line at 4. And what I get a lot of times is people just draw in the whole line at 4, like they'll draw it the whole way across and then just erase the part that they don't want. You can do that too, as long as you're writing with pencil. So continuous or discontinuous? All right, so discontinuous at x equals 3. This seems like this is going well. All right, this one has 3 pieces in it. It's not any harder. There are just 3 of them. Okay, so the domain, it's like our flip book got cut into 3 sections. That's all it is, all right? So you've got x cubed. We want to graph that for smaller than 1. Now that's the parent function. So it's still going to be centered at the origin. It's just instead of getting the entire wiggly graph, we only want from 1 and then everything smaller than that. You can plug in 1. It's okay. You can plug in 1, be 1, 1. You just have to put an open circle there. And then if you plug in some numbers that are smaller, you would get -1, -1, and it's going to wiggle like that. So again, it's the cubic graph. You just chopped off part of it. And again, some people prefer to draw the whole thing and then just erase what they don't want. You can do that too. That's fine if you're writing with pencil. Now this is kind of interesting. We want 2, but only when x equals 1. Well, that's just going to be the point 1, 2. All you get is a point there. That's it. That's not a domain like over a span of values. That's only specifically at x equals 1. So that's just a single point there, like floating in space. And then here we've got a square root graph. So it went right 1, up 3. So right 1, up 3, but I need an open circle there because of the inequality. It's only greater than. And then I'd like some more points, so let's plug in some more numbers. Let's try 2. I'm just picking a number bigger than 1. Let's try 2. See if it works. If it doesn't, pick something else. 2 minus 1. 1, square root of 1, 1, plus 3, 4. So we get 2, 4. And then let's see if you guys can come up with another number that will work. Like what's another number we can plug in where it's going to turn out like pleasant? Good, 5. 5 minus 1 would be 4. Square root of 4 is 2. 2 plus 3 is 5. So we get 5, 5. And I kind of just talked you through that verbally, but if you wanted to actually draw the XY table, you could do that. That one looks cool, like that point floating out in space. That's neat. All right, continuous or discontinuous? Yeah, discontinuous at x equals 1. And then this last one, the cut happens at 0. We want -x for everything before 0. That's a line. It's going to go through the origin and have a slope of -1. It's just at 0, you would have an open circle. And then you can use that slope of -1, that down 1 over 1. So the line's going down, negative slope, down 1 over 1. And it's just at 0, there's an open circle. So you could draw in the whole line again, and then just erase the part that you didn't want. And then what is this line going to look like? Just x. What slope does that have? Yeah, +1. And again, starting at the origin, except what's going to happen to that open circle? Yeah, it's going to get closed and then slope of positive 1, up 1 over 1. So I hope that you're like, oh, look at that. Like anything you want to comment on or like notice or the absolute value graph. This is another way you can write the absolute value graph is as piecewise. And then continuous or discontinuous. Continuous. Please don't tune me out because I want to say 2 more really important things. All right. The rest of the time will be free time and there's quite a lot of it. So please continue to give me your attention for the last 2 things. We're going to do a quiz, but not next class. It'll be the class after. The reason I printed this here for 2 reasons. First, so that you could start looking at it now. And secondly, because I just had room on the paper. And so I was like, oh, well, I have space on the paper. I'll just go ahead and print their quiz objectives right there. But that's not next class. It's the class after. Okay. Yes, next class, we're going to just do more with piecewise functions. All right. And then the last thing I want to show you, and I'm going to keep this recording here. I want to go over what the homework looks like on Delta Math, because it is a little, it's good, but I want to show you how it looks. It's a little weird looking at first. Let me pause this recording and get that up, and then we can look at it together. All right, so let me share my screen, and we can look at this together. Okay, this is what it's going to look like in your homework. We'll do a couple of these together, okay? We're going to graph this piecewise function. The first function, that's absolute value. So which one of these am I going to choose? The V shape. So when you click that, it puts that on there, and then you can move it around with that center point. Now this one, it's just absolute value of X. So we want to leave it centered at 0. And here's what got me when I looked at this. I was like, well, I'm not done. You have to click done. Then it will let you decide the domain. So you click done. And then with these arrows, you can change like where you want it to be. Does that make sense? So let's see, what was the domain on that part? We want it smaller than 4. So I'm going to bring this in until it's at 4 and open or closed circle. Open. Right now it's closed. All you have to do is click on it and it'll make it open. You can toggle between them. And then you click done. All right, now we're going to do the next piece. This one's square root. So which one of these are we going to choose? Yeah, the first one. And what direction did it move? Right 4. All right, so with that little circle, you can move it right 4. And then done. That's what confused me. I was like, why do you have to hit done? But it makes you hit done to do the next part. And then it says greater than or equal to 4. Now it's already like greater than or equal to 4, but I'll bring that in. And then open or closed circle. Closed. And it already is. So you would hit finished, submit. Don't accidentally hit that button. You will have to start all over. I did that once too. That's like a huge bummer. Do you ever like do a whole thing and instead of submit, you hit cancel? Oh, that's like the worst. All right, and we'll do one more together and then it's gonna give you a big check mark and it'll be like, yay, you got it right. Or it'll glitch out and not do anything. I don't think I can give you a grade for it then. Let me just try and refresh the page. Ah, okay, Delta Math is down currently. It'll come back up. You have across the weekend to get it done. Does this make sense? Okay, I was gonna do another example, but apparently the website's being like a little bit annoying right now. All right, but do you understand how to do the homework?